This- oh, yeah, this- let's see. How do you tell if this is still recording? Yeah, the mouse here is actually messed up. There's gunk on it. Wow, that's probably toxic ink. Uh, so let's see where it says recording or not. Let's see. Because it doesn't record sometimes. I'm trying to figure out. Let's see. Let me just start this one running. Oh, no, no. Let's see. I'm going to. So did everyone like the homework should be all set, right? I guess I didn't post it up like right away. Anyway, the homework's there. So that's okay for everyone. Everyone's got the homework. Good. So I was going to go over today, and then actually first, there's a guy coming to talk on Kelly Williams was Thursday, but he has his kid school something or other, so he moved it to Tuesday. He's got it's like a biofilms company in Cincinnati. He's known like pretty well known in the plastics films business, and he's like a head of like the top guy for recycling plastic films. And he's in Cincinnati, so he's going to come in and talk. So I think it should be pretty good. Anyway, so I guess like for the last speaker for Carrie, I thought the turnout wasn't that great. So I thought I'd try to like sign up sheets don't really work, I guess, you know. So I thought I'd do something, try something like take a picture of yourself, and then I'll have a thing like you have the homework is like 100 points. I'll put like 50 points, post your picture. Does that sound like it could work? Like everyone's got a cell phone, then it's time stamped in the picture. You just throw the picture up into the, I'll put it, you can put in like a picture file for every time. But maybe that'll bring people out. Maybe it might, you know, it might not work. Yeah.
Spring of next week, the end of October,
Yeah, if you got a problem, just
Okay.
put something up that says, just say email. Actually, you'll have to put it. So if there's a thing in the homework, just put something in there. It's like,
Because I could literally take a picture like.
yeah, I'll put it so you can put a PDF too. Yeah. Or take a picture wherever you are. Don't worry. Then I can, because then, you know, it's file restricted, so I don't really want to have PDFs up with timestamp on it, I don't think. Maybe you can, but if you take the picture, even if you don't post it that day or whenever, you know, it'll still have its stamp from whenever you took it. So I think I can figure it out. So, and then I don't know, it might be a little weird, but I think it might bring some people in too, because it's supposed to be like 40 on undergrads in here, and then like 6 grad students. So we got like 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, there's 15 now. So there's kind of like 30 some odd missing, right? So if we could get like 20, that would be good, you know? Like I'm not, anyway, we'll see how it goes. But I mean, the homeworks have been good. Everyone's been doing the homework, so that's good. But just like, it'd be good to have people like for questions and things. Mostly I want to see like have a conversation with the people, not like just have them give a lecture and watch it on Zoom. Because that, I mean, there's plenty of stuff on the internet that you can do that with about recycling. But if you get into that interactive mode, I think you'll find out that you get a lot more out of it, you know, because you'll basically that's the way to go. You know, because you can, yeah, well, that's all right. I mean, like I said, 20 would be pretty nice, you know, but like 15 isn't, it's not that great. People are coming in, like they're taking time out of their work and stuff. The business people, you know. I don't know. It's just like, there's not, well, there's quite a few, but anyway, there's gonna be two more. I got Kelly Williams. Katie Beers is on Zoom anyway, but still, I'd like to have people in here because we can, like the interaction thing, I guess, can still happen with Zoom. We can try to do it. Yes, I'm at Kulkarni's somewhere in here. And then one other person, I forget. Oh, someone from P&G. Kieran's her name. I don't remember her first name. But anyway, she's the top recycling person or something. So, I mean, that should be interesting, I think. Anyway, does that sound reasonable or I don't know how much of an effort? If it looks like it's like way too much effort, then I can figure something else out, but that seemed like off the top of my head, like a way we could do it. Just, yeah,
It's just an idea going out to put like a number, like a word on the board, and so like we have to be here. I mean, other people have things, but you know, send email about that. Like if you come in, you can see the word on the board, and like put that in like a Cleveland campus or something.
I have, then you can share it with your friend, so it doesn't work. A picture is like pretty much you were here. I mean, it's not, everyone's probably gonna get an A in here, you know? So basically, it's not gonna matter, but basically it might motivate some people to show up. I mean, it's gonna be hard not to get an A in here. You'd have to try, you'd have to like totally not do the homework and like, all right, so we do have one more person that went into group 13 that like didn't show up for the homework, but you know, because it's group homework, once you turn it in, then they get the grade automatically. You can't undo that. It's kind of like a fault in that system. So for that week when they weren't there, they still got the grade for like weeks on. So I just put them 13 all the way through. They'll have to do it all. But generally, like in the past, when that's happened, those people end up being the top. They give the top homework of the class, you know, because basically they're just doing it because I don't know. It's whatever. It ends up being pretty funny. And then in other cases, people are like, say like, oh, I don't want to do group homework. I want to do it alone because because no one else is going to do anything in the group or something. When they go on their own, they do the worst. Like they do terrible. They think like, I'm going to perform so well on my own, you know, and it turns out, no, it's just like you were doing better in the group. So it's pretty funny how that turns out opposite of what you'd think. But anyway, so yeah, next Tuesday, Kelly, and I'll send out an email and like warning, like come in or whatever, take a picture. I mean, you could come in, take a picture and leave, I guess, you know, it'd be kind of awkward, but we'll see what happens. Yeah, we'll get like 40, 50 people and like 30 of them will take a picture and leave. Like a protest vote, you know, but anyway, so Kelly, that should be pretty good. Like I talked to him on the phone and stuff. He's pretty good. And then Katie Beers should be good too. The other two people are really good. Like, so basically all of them are worth the time to come in, but all right, so that's said. So that's that. If you got other ideas, let me know. But I think the thing on the board, I think I've seen that done before, but things that you can share with the other people. Not that I don't trust you, but I mean, that's what I would do, you know, so it's kind of like, I'm not sure it would work. Let me get this thing downloaded. I still don't feel like Zoom is being recorded on this. Look at this. It doesn't say anywhere here that it's being recorded, right? More doesn't do anything. Maybe I'll kill Zoom and start over again. That didn't do anything. That's how we started, so. It must be doing it. Oh, here, it's got a recording thing up there. I've had problems with the recording, that's what I'm saying, but anyway, okay, that's okay. All right, so I wanted to go through tires. So I've been working in tires for a while, you know, with various aspects of it. Now we're doing microplastics from tires. So anyway, tires is something that's warm to my heart. Oh, yeah, that's a good point. Sorry. Anyway, so yeah, you didn't see I had the calendar up before. So anyway, Tuesday, Kelly Williams is coming from, I forget the name of his company. It's like something biofilms, whatever, but anyway, so I kind of know things about tires. So it's kind of like we could talk about it, and it is a chunk of the plastics recycling market. So anyway, so tires are a problem. Like they take up a lot of space in landfill, and then they have so 75% is air, like when in the space that it takes up. And then when it's buried in the landfill, it kind of fills with methane gas and eventually rises up. So it rips, the landfills are made of layers and it rips the thing apart. So they end up piled on top of the landfill, even though they were buried, right? So that they're an issue. Anyway, so people just take the tires, you can just use them for other things. Like this is in where's this, England. This is the Thames River in London. And they use these to keep the people live on these barge things there. They go up the canals and things. So they use it to keep the barges from hitting each other. And this is an artificial reef or this is just a seawall somewhere in England. And this is pilot tires, and that's somewhere in Africa using tires for chairs. These are artificial reefs being made, and that's kind of what they look like after. So it's possible to just use the tire, like a totally worn out tire, for other uses like that. Let's see, why don't I go back to, oh, now it gives me that. Okay, so here, sorry. See the tire files. So there's this talk. And oh, this is just here by accident. That's left over. There's some videos. There's a talk about the 6 PPDQ that I'll talk about. This is like a total thing on the tire shredding, so I'll try to show some of that. Recovered carbon black video. This is 3 hours on recovered carbon black. I don't know. I watched some of it, but and then these are 2 books. Like the top book is kind of the first set of slides in this, like the first 10 slides are from that book, kind of the highlights of it. So there's 2 books here too, and basically on this subject. And I think they're the only 2 books on it, and they aren't really books, they're like collections of papers. But the first book, the first 5 chapters, don't read the first chapter, but the 4 after that are pretty good, almost like a book on tire recycling. So they're pretty good. I'm gonna put up some more other video links here. So it turns out like California has a lot of videos on tire aggregate use in highways and in light rail, and also for preventing landslides and things. So I'll show some of those. Basically, I'll put those links up there too, because I think they're pretty useful. Anyway, so I wanted to show that stuff's there. Then anyway, this is kind of from that first book, like kind of what they talk about, what is a tire, you know. So it's got tread, like the tread compound here, and that differs for trucks, that's all natural rubber, and for cars, it's SBR, styrene butadiene rubber. And then it's got, so because natural rubber has better tear resistance and it wears better, it's basically trucks have like 18 tires, right? So they don't need to have like super grip on each tire because they have so many tires, there's a lot touching the road. Cars on the other, motorcycles, have to have better grip. So SBR is a better grip. So you're looking at like these are the things that tire companies talk about, like wet and dry grip, which you get from a dynamic mechanical test. And then traction, they have ways to test all these things. Durability is just the wear. And then these things are a little bit more esoteric, right? So fuel economy isn't, that's related to, well, basically all these other things are linked to fuel economy. So anyway, so the classic tire is going to be like carbon black, SBR rubber for the tread, and the sidewalls can be like a mixture of natural rubber and butadiene rubber. right? And then the bead is made out of another kind of rubber. So there's like 3 kinds of rubber in this. And then it's really composite. It's got this kind of woven fabric and then steel belts or some kind of metal belts. Right, so a composite material. So it turns out like by grinding this down and using magnets, you can actually separate all these components from the tire, and end up with a crumb rubber that doesn't have any metal in it, and then the fiber is kind of a waste product that they throw out. So I'll show you some kind of videos of how they do that. So basically, you can buy enough machines to do that whole operation. Anyway, so carbon black's been replaced partly by silica. So you need some carbon black because when you run down the road, it builds up static electricity. And if you didn't have carbon black to conducts electricity away, then you'd arc all the time when you go down the road. If you put in silica instead of carbon black, you get better mileage. So what they call the green tire is actually still black, but it's got silica in it, right? So Michelin invented this green tire. You get much better mileage from it. Then, so basically, like this is going to be a mixture of carbon black and silica in the tread, basically. Then the rest of it's carbon black rubber. Right? So there's different compounds throughout the thing. And then it's got steel belts, and then textiles like polyester fiber. And then it's usually got a lot of oil in it. So basically it says 8% here, but it's like 10 to 15% oil. So just the oil makes it processable, and it so the tire ends up almost being like a gel, like a rubber gel with oil in it. And then with a lot of fillers, like a huge amount of fillers. So the rubber part is it's a minor component of the total thing that's going in, right? And each of these sectors, it's going to have a different rubber composition and filler composition to make the different kind of uses for tires. So airplanes, like they're only gonna get like 7 to 10 landings out of a tire. So they have to continually swap out tires on airplanes. So you don't think about it, but basically they go through a lot of tires. And in an airplane, I forget, a commercial jet has something like 20 tires on it. There's quite a few, so basically they're burning through a lot of tires, literally, because when it's a stopped wheel, when it hits the ground and it just smokes, it burns. So they're torching the rubber every time they land. The other things, these are giant tires, so they're kind of different, more difficult to handle somewhat. And the truck tires, so both the truck tires and the aircraft are going to be retreaded all the time. Like truck tires, I think 10 times, and aircraft some like 15 times. So they use the same body. You can see it's kind of a high-tech system, and then the tread wears out. So the rest of it doesn't really wear out. So basically you can replace the tread on this and then just keep retreading the thing. So I have some videos on that stuff too. What else? Anyway, it's more tires every year. There's a couple reasons why. Basically, people in the world generally are getting richer, and the first thing they want to buy when they get enough money is a car. It's like when they get a car, it's got tires. So you end up with more and more tires. And the population is also exponentially growing too. It's like more people means more cars, more tires. So basically, and the tire companies are more than happy to make more tires for people. It's like that's growing. And so incidentally, like the natural rubber part of this is a natural, so it's not a synthetic, it's not coming from oil, but the SBR is, and the butadiene rubber are. So basically the truck tires are almost like green tires, you could say, because they're made with natural rubber mostly. And the passenger car tires aren't so much, right? So if you wanted to have thinking that you're not taking from fossil fuels to make the tire, it's possible to do it if you use natural rubber. The only reason to use SBR and butadiene is because the performance is better. And there's a cost issue too. But basically, it could be done that you could make just natural tires, like at least non-fossil fuel source tires, which would be better for the carbon load, I guess. So the miles traveled is going up, but this is disputable. So it's kind of like when you get more, so if you say your family has one car, it's going to have a lot of vehicle miles, but if you buy another car, then suddenly the vehicle miles goes in half. So as people get richer, so this goes to 2019, I think the vehicle miles is like dropping somewhat now, because of this idea that you get multiple cars and you get less miles per whatever. And the population's growing and the number of cars is growing. So kind of I guess the ratio and number of cars to population would be like a sign of like people are better off than they were before. Like they have more money, so they can buy. Oh yeah, here, average annual kilometers per vehicle is dropping because they buy multiple cars per family. So anyway, so some of these are kind of interesting for me, but GDP and number of cars is basically a straight line. So that means more money to buy a car. And then, so China is buying a lot of cars, a lot more than they had before. Right, so before they had just rich people had cars, and all of a sudden they're becoming like a middle class country. Right? And Europe's kind of staying the same. North America is about the same. So China's kind of driving the growth in the number of cars. So park is a registered vehicle, is this unit. Park. I don't know, I had to Google that, but then this is just like by sector where the growth is and the number of cars. So and then so it's in terms of solid waste, right? So paper wins. Paper's got the most solid waste, but it's recyclable mostly. And plastics is about half of the paper. And glass and aluminum are smaller players. And then rubber is the smallest player. And then of the rubber, most of it's tires, but a lot of it is, some of it isn't, right? So basically, of plastics, most of it's packaging in the same way. Like this is a subset of the plastics, and this is a subset of the rubber, right? So if you look at the numbers, you'd say like that's a minor problem, but it's a big problem because of the issue that it's a big item. So it takes up a lot of space and it's very visible, right? So if you have like, and also it floats, right? So if you go to the beach, like in, let's see, where's that picture of the beach? Maybe it's coming up. Yeah, it's coming up, I guess, sorry. Anyway, let's see, I was here, all right, yeah. All right, this is just the same thing as like the composition of the tires, except it's done by weight, and then somehow the numbers shift around a little bit from that other plot, but and then so this is kind of the list from that book. This is the first book that I showed, which is worth reading. I mean, it seems that's a pretty good book. Don't read the first chapter, which is kind of weird, but the next 4 are pretty good, and they're all short, you know. And then the rest of the book is like technical details of like civil engineering projects with waste rubber and things. It's not, I didn't get anything out of it really, except what you can get from just surfing the internet if you want to know about it. Anyway, so let's see, hide this guy again. So these are kind of the options. So reuse. So there's actually a pretty big market in used tires, believe it or not. And I mean, especially with it. So when I was young, like I bought used tires at a junkyard for cars. Like that's basically my source of tires, because it was like at the time it was like $10 for a tire or something. So it's so cheap. It was kind of the way to go if you were poor, you know. So anyway, there is reuse, and you can get it on the internet. And there's also, I'll show you this Liberty Tire Recycling Company. They sell used tires. So they buy bulk tires from like tire, what is it, discounters, Tire Depot or something. The places that replace tires. And they just get truckloads of tires from them. Like what Carrie Harms was talking about. They collect tires and they give them to that retailer place. Then they're going to sell them to like Liberty Tire, which has a collection site in Columbus, right? So basically they grind tires up. The tires, so they'll inspect the tire, and if it's something that has tread on it that could be resold, like they'll get money straight up from that. And you'll see like the reuse, like they're still going to make $50 on a used tire. It's like it's a big profit for them because they got it for free, or someone paid them actually to take it. Like they made paid them like $5-10 to take the tire, and then they can sell it for 50. So that's an automatic, just do that. Then also, so if the sidewalls, so they can inspect the tires and tell if the sidewalls are good and the bead is good, and then they can retread it. So the retreading option is like you save 65% of the the fossil fuel footprint if you retread a tire. So if you do that 8 times for a truck tire, it adds up. Like it's going to be a pretty big savings for them. And then recycling here in this table isn't the standard definition. So it's really downcycling. So you take the tire, which is a highly engineered item, and then you got to grind it into crumb rubber that's going to be used for fill. And I'll show you some examples of the fill. So you can use it for roadway fill. The advantage there is that it's light. So it costs to put rubber in instead of aggregate, which is rock. The money that it costs to do that, to truck it, to mine it, to truck it, the rubber things that they put in end up costing like 20% of what it would cost for rock. And it's got advantages that it's lighter. Okay, so if you're on a cliff, so if you have a road on a cliff and you get landslides, like in California, when it rains out, you get the landslide because the water soaks into the soil, and the combined weight of the aggregate and the water makes it collapse. So if you can reduce the mass of the fill that you put in under the road, you can prevent the landslides. They found this. So California has like a lot of interest in ground up rubber, believe it or not, for roads, and also because they have earthquakes. So if you make a railroad, they dig a pit to put the rails in, and they fill it with aggregate, usually like rocks. If you fill that instead with rubber, it turns out when there's an earthquake, like the rubber absorbs all the shock waves. So the railroad doesn't get this bending thing happening, you know. And also, like when the trains go over it, there's no sound because it absorbs all the sound. So they found out that like using rubber with railroad makes a lot of sense. Like it's a big improvement over rocks. So, but again, like rocks are not a high value item. So it's kind of like neither really, it tells you what the value of the aggregate of the rubber, crumb rubber is too. It's like basically not a huge cash thing, but Liberty Tires made a big business out of that. And there's a bunch of other competitors in it too. Anyway, so recycling means downcycling. Like you start with something that costs $150 and you're going to sell it once it's ground up, you know, a couple bucks maybe, right? So it isn't after a lot of processing. So it's really downcycling. Recovery means you're going to pyrolyze it, just like the plastic. So pyrolysis works for everything, you know, so you can pyrolyze anything. The difference here is that if you do pyrolyze it without, so because it's 30% carbon black, which is it's a high value item, believe it or not. So it costs a lot. It's engineered. So there's companies like Burla in Atlanta that make just soot. And so they sell a lot of it. And tires are one of the main uses for it. And the tire's 30% soot. It's basically, if you pyrolyze it with no oxygen, the soot remains soot. It doesn't degrade. It's already at the lowest state. Like that carbon it's not going to degrade into oil. So you end up with soot mixed with ash, which can be separated into this recovered carbon black. And it now, because Europe has said that everything has to have a circular life. So this recovered carbon black in Europe has become a huge business. There's a lot of startup companies. They're like figuring out how to get the carbon black out of a pyrolyzed tire. So you get oil and you get carbon black from it. And the carbon black goes back into the Burla, like virgin carbon black as a blend. And then you can make tires again from it more or less. There's a little bit of a lie. And then fuel. So fuel mostly in concrete. I'll show you a video of the fuel in concrete, which is kind of interesting, from Indiana. So you can see that. See if this guy's going to work. So this book, this is their idea from the book, you know, to break it down into these four. It's kind of like other people have broken down into levels. So level one is just grind up the tires, right? And it still has steel belt in it, and then and it's got the fiber, so everything's in it. So you can just use that. Say like this is what Rumpke does is level one. They have just bought I'll show you a picture or a video of the grinder machine. You just take the tire, throw it in, it chews it up, gets it down to kind of like 2 centimeter, maybe 5 centimeter chunks of rubber. So that's still identifiable as a piece of a tire. And they're going to use that. So normally, if you have a landfill, you're going to just dump garbage in, but you can't just keep dumping garbage in for some reason. It'll have a landslide and it'll blow up too from the methane or something, right? So you need to put rocks in. So after a day of garbage dumping, you put in a layer of rocks over the top. And then the whole landfill is gonna be like garbage rocks. It's like a layer cake, right? And then it goes up to some point when you decide like it's Mount Rumpke, we're done. Then you put a golf course on top of it. That's what they did in Columbus. So you're going down 71, right after 27, or the Beltway around Columbus and heading to Columbus on the right-hand side is as it was a golf course built on top of the landfill, but then they stopped using it for that purpose. I don't know why. Now it's just a wasteland. Basically, it was a golf course on top of a landfill, so they can be used. You can use that land for other things after. I mean, anyway, so that's a level one. They're going to swap out using rocks for the rubber crumb. They're just going to take this first stage of grinding it to like maybe 5 centimeter chunks, then just bulldoze that over. The nice thing is it's got great drainage, right? And it's light, so it's got a lot of advantages over rocks. And it's kind of just also disposing of tires. So if Rumpke's collecting the tires, they can just grind it up and use them in their operation, whatever they get. If they get extra, they give it to the Liberty guys. Right, so anyway, the next step is like you can, and I'll show you a machine that does like separate the entire thing into the component parts. So this number one is going to feed into that. Then it's going to somehow rip it further down to smaller pieces, and then separate the metal, the steel. So the steel's magnetic, so you just have giant magnets that pull out the steel, and the rubber and steel and fiber. So the rubber and fiber go in one place, the steel goes in the other. So you can get 98% pure steel out of this, which is, and it's high grade steel because the steel reinforcement is like the highest grade steel, right? So basically that's pretty much one of the major value addeds of tires. You can get the steel out, which you can do mechanically. And then I think you grind it up more and just the fibers will come out eventually. And it turns out like polyester fiber fluff that can be blown off. And that's just disposed of as garbage, and then you end up with pure rubber that you're going to take. So that's kind of level 3, and you're going to dye it and make playground things like green playground mats. And also at that point you can use it as a fill, like, so the sports fields are going to be like multiple layers. There's a cushioning layer on the bottom, so you're going to use this stuff as a cushioning layer. If you grind it further into a powder, you can use it as part of the next tire. So there's like 4 layers to a sports field. I didn't put that in here, but basically the rubber can be 2 of those layers, this ground up tires, right? So there's a lot of uses. And then finally, the fourth use isn't exactly in sequence here. It's pyrolysis and chemical degradation, which is going to lead to this this recoverable carbon black. So he says pyrolytic char, which is recoverable carbon black. So that's a big thing in Europe. It's kind of becoming an issue in the US, I guess. It's a little bit like whether that's really economical to go through that routine is a question. But anyway, so there is a huge interest in this kind of tire thing. And if you want to look at it, like this is nice what they did in the book there. But so basically you can directly use the whole tire, you can make a reef with it, or you can just reuse by-use tires. You can mechanical treatment. So this is grinding it up. So you can also, in this point, you could retread it too. So this direct use would be using it as a reef, selling it as a used tire. Then one step down from that would be retreading it. Mechanical means you're going to grind it up. At that point, you're making the fill for the landfill or for road work. Then next step, further treatment. See, marketable products would be the aggregate for road work. For the steps and size reduction, or you can do pyrolysis to make kind of fuel from it, and recoverable carbon black is a side thing. And further size reduction, and each step has kind of marketable products, and you further, it's almost like processing to get to the final thing. So when you go down that route, though, there's this issue, which the book brings out too, and I haven't seen this anywhere else either, but it's kind of important. When you grind it up, you lose 5%. I don't know where it goes, but basically there's a loss. I mean, you can imagine there's the loss in every process. So as you go down, if you go down that pyramid, you're kind of getting to the point where you're only recovering like 30% of the tire they started with, and 70% has gone somewhere else. Right. So I'd never seen this presented before, but it's believable that every time you put it through another process, you lose more stuff. Maybe they just estimated this because it's just solid like 10% losses, right? So anyway, there is some issue about the more you process something, the more you lose. So you're kind of, there's a trade-off between those, whether what the best thing is. This just shows like the size gets reduced as you process it more. So there's products. The whole tire is a product. The cuts would be like for the landfill. The shreds could be landfill too, or they could be for other uses, chips, then granulate where you separated the rubber from the steel, powders, fine powders. So the size gets smaller and smaller. That's kind of obvious, I guess, but this is kind of like the historical thing of it, like how we're getting better, I guess. We started with 62% was going to a landfill. People got upset about it, and then gradually the recycling, which means actually downcycling into crumb rubber, has grown until it kind of saturated the market, I guess. Like for some reason it stopped growing. And then energy use was low and then became high when people realized that this can replace oil and it's a lot cheaper for certain processes like paper making. So International Paper seems to be the main player in that. I tried to find some things about it. Everything I found was International Paper. And a lot of it was like, people don't want to have people burning tires to make paper in their town. People are upset about it, you know? So but the majority of what's listed usually is like cement making, cement kiln, and paper making. So cement kiln makes a lot more sense than paper making, because cement kiln is running at 1650 C. It's like 3000 degrees Fahrenheit. And at that temperature, there's nothing left of anything. A tire, when they shoot the tire into the kiln, it lasts 2 seconds. So there's nothing left at all. And also the steel belt, so that when you make concrete, you need some iron in it. Or when you make cement, you need some iron in it. So basically the iron in the steel belt actually adds to the concrete that you're making. So it's actually a double benefit, I guess, but.
It works specifically in the paper industry because of they have a recovery boiler for their stuff. So
Okay. Because they're already burning like bark and things and.
So when you do the paper industry, it's when you're making the paper, you're splitting up the wood into lignins, which is the byproduct, and then the pulp. Pulp is what you make paper out of.
Yeah.
But then you go through a whole process of doing the burning the lignins stuff, and it's usually referred to as black liquor. But the recovery boiler is specifically made for that stuff.
I
and
see.
It's got a lot of nasty stuff in there.
Yeah,
It's
yeah.
not any different than throwing.
I can see, all right, that explains it. I know about black liquor. I tried to get some, you know, because we're doing like we're doing like rapid prototyping with wood and with the DAP guy, Christoph, guy in DAP anyway, but basically, so we were looking at like anything we could stick into it. And then it's like, well, why don't we use this like lignin stuff? It's almost the same as cellulose. It should be like a good binder in this thing. It's like you go to find it, and the only place you can buy it, so that there is purified black liquor, but you can only buy it from Finland. And they were selling it like $100, like 100, $200 a liter or something. Like, so it's like way
caustic. Like you don't want to deal with it.
Anyway, yeah, so I know they burn it. Yeah, but I thought, well, if we could use it in this process, it might be useful. But yeah, it's pretty interesting. So they're already dealing with the nastiest thing you could possibly burn. So tire looks pretty good to them. Okay, that makes sense. I mean, otherwise it doesn't make any sense. Like, is tire really the first thing you would think of? You know, it's like, but anyway, in the kiln, the concrete kiln is so hot, it doesn't matter what they send, what they put in. You know, so they have this place. I'll show you the video. It's kind of interesting, but to me, but some things that are interesting to me might not interest you, but then it's interesting in this plot. So it's like, this is mostly Europe, I think, European Union, right? So, but retreading, so European Union, there's a lot more retreads than there are in the US. So it's kind of funny, you know, like you wouldn't think that, but anyway, the percent retread is like dropped there, you know? So I think this is for all truck, car, everything. So it doesn't make that much sense. I don't know exactly why that is. And then reuse export. So you'll see, I'll show you the retread company, and it's not in the US, you know, when they get it, it's like the first part of this video, there's a shipping container, you know, and it's got the lock on it, like they put like a Ziploc on it to keep them shut when they ship overseas. And the guy goes over, the first thing he does is break the Ziploc on the shipping container and like open it up, and it's full of like US tires, you know? Basically, like, I guess we must be, because, all right, the ships come from China to the West Coast, right? Basically, they're full when they come, they're empty when they go back. It's like the shipping from the US to China is really cheap. So basically, you can ship anything back to China for almost nothing, including like tires. Right, so basically apparently we must be sending a lot of tires to some place that they're being retreaded and then they're being reused. Because I don't remember where the company was that was doing it, but basically I have a video where they go through the whole operation. And there's two ways to retread and they show both of them in that video, so it's kind of interesting. Anyway, so, and then landfill is diminished down to almost nothing because most of the landfills won't take tires. Like, I don't know where the 9% comes from because Rumpke won't take tires for landfill. No, and if you look anywhere, they're banned from landfills, except maybe in Texas or someplace, you know, or someplace deep south or whatever. Basically, anyone with their head screwed on right is not taking tires in landfills. So the 9%, that number doesn't seem believable either, but maybe it's private landfills, meaning like in the backyard or, this is just a list of everything they could think of, like tram rail beds, that's California. I don't think that's being done anywhere else. But they've had great success with those things. Artificial reef. And there's certain locations that use certain of these things. This is more of the same thing, but like, like the crumb rubber, what you can use it for, like mats and road surface and things. So I'll show you some videos of those things. Right, so that's from that book. So it's kind of like series of, you know, things here, but this is somewhere else. I got this stuff, but so 1990, we were throwing out 1 billion tires a year. Then 2015, we're down to 67 million. So that's good. Like tires to landfill. Oh, this is the beach. So because tires float, right? So this is an issue. So basically, they kind of float. So basically, they'll show up on the beach. This beach is pretty nice though, because it's got all the possible plastic waste in it. It's got there's some aluminum, there's PET, there's polyolefins here somewhere, like here. So you can kind of pick out all the plastic waste problems in this beach in Ghana, you know. I'm not sure. I guess you'd get used to it when you went to the beach there, but I mean, anyway, that's what it looks like. So then so in 2017, these are the cuts on the I forget where I got this, but the cuts for where tires are going to, and it's saying like 15%, which kind of agrees with that plot. But again, like, I don't know where the landfill is that that's going to. And they break it down into sold as used tires, and the cement issue. So like 37% of tires are going to cement manufacturing, which is, so I wanted to mention a little bit about that. Then ground rubber, I'll go through that. And then civil engineering, I'll show you a few things about those things too. But so anyway, this is the largest tire landfill in the world. It's in Kuwait. It's still there. This is like a video. Oops, this should link to a video here. Oh, this links to a video. They had a big fire there, I guess in 2020. Oops, what did it say? Let's see. I think I have to do something here. I have to enable editing. I have to enable editing. And I have to go back here, then I can do this. See, I've learned you can teach people things. That's when it burned. Then can you zip ahead on this? Kuwait's like, well, we fought a war in basically it was a super rich country. They don't, everybody has like their fancy car. So I guess the tires are out, they just put them in this few. There. Anyway, so that, just saying, you know, that there's a giant landfill in Kuwait. You can see it in the Google Earth map thing if you want. Actually, it's hard to see because there's sand mixed in, and these things are actually, it looks like it's just continuous, but they're in like squares. So there's a lot of tires. So anyway, just kind of interesting. That's where maybe that in the world, maybe that's like where the landfill issue is coming from, because in Kuwait they don't care. And this is a US landfill, and these tires all like rows, so you can see it's a mound, and the tires have risen up and then shown up on the top, like farmers, if you live in a place that's rocky, like New England, every year they plow and there's more big rocks that come up. Like, where do the rocks come from? Nobody knows. Basically, they have to lift the rocks out every year, right? And it doesn't matter how many years, there's still rocks. So tires are kind of like that. They float to the top. People have come up with this methane theory, but basically big things tend to rise up, I think, and if you have soil. But anyway, so I'll talk about this issue, this 6 ppdq. So if you look at EPA, this is like one of the main things that everyone is looking at this thing. So it's like, all right, so plastics, like people talk about environmental problems with plastic waste, and like in terms of chemical problems like leaching out. And so everyone has been looking for this. Finally, they found it, and it's in tires. It's called 6 ppdq. So it turns out it's not really that bad. It only kills salmon, but salmon are like important in the Pacific Northwest. So they've dumped a huge amount of money into like trailing after the 6 ppdq. It is a problem, but basically it's something that people have been looking for a long time. Like plastics are so bad, they last for 1,000 years and they leach out all this stuff. Then you say, like, what stuff? Well, they say like phthalates, plasticizer from PVC. It's true. Yeah, that's a endocrine disrupting chemical. So it's not good to have around. But nothing is really like, this is killing like something that people like attached to, like salmon. So like basically the 6 ppdq has become like the main topic, even though it's probably a minor issue, because they've tested it with other animals. It doesn't do much. But basically, anyway, if you in the environmental field, that's one of the main things right now that people are talking about. That's a landfill picture. So basically every day you're going to fill up with stuff, and then you're going to like cover it with something like rocks. So you can replace that with crumb rubber if you want, or this rubber shreds. And then that's what Rumpke's doing now. And then basically they get rid of tires and they get rid of so basically it acts better than rocks did. But if you put whole tires on again, it rises up and rips apart all these layers. So the whole system falls apart at that point. Anyway, so you can buy used tires. Like, this is a place. I put in Dunlap, whatever size. You can get any tire you want for like kind of cheap. I mean, $50. It's a third of the price, I guess, of what the tire would have been. That's for 2. And then Liberty Tire actually themselves, Tire Recycling, actually, they sell tires too. You can buy tires from them. So basically everyone's in the used tire business, I guess, somewhat lucrative. Then that's kind of step one, just take the tires and resell them. The other step would be like retread the tires, right? So this should work.
Stop overpaying. Get thoroughly tested like new tires that give you.
Oh yeah, they're selling these tires, right? Skip. This is just 2 videos. This is a place to get. No, this is the video that I ever. But this isn't in the US. This is the beginning of it. I'm gonna have to skip through because this thing's going to I like this. See, so where is that? Is that Korea? So it's Korea. So so it's a shipping container. That's got to come from the US. So I guess we're shipping to Korea. So you broke it. So that came from a ship that was sealed, but you picked it up. Those are like US guys. Well, and they're gonna do retreads for Korea, I guess. Maybe they don't have enough beach tires in Korea. I don't know. Some of these could have been sold. See, they still have tread on them. They could have been sold with used tires. These are all the retread tires here. So it's a pretty big operation. Yeah, they have to go through, they check them, they wash them. And just zip through. You can watch this. This is up on the web somewhere. I don't think. We're gonna grind up the surface here to take the those 2 ways. They can cast in the thread into a long strip, and then cut it, and then put it around and staple it onto it, good glue. Or they can actually make it, just like the process of making a tire, they put it into an autoclave, they can press it out into a nose. That's a, there's two methods, we both, both methods. A little bit, pretty interesting, I think, but. I'm not sure what he's doing here. I think he's finding like that spots or something. Kind of labor intensive. I guess if you're gonna get like $100 per tire or something, maybe pay, I don't know, $10 to get them to big profit, I guess. Oh, he's putting down a rough, but I'm not sure. Oh, he filled in all the rivets the other guy drilled out. And this is where they're making this new track. So we gotta have some code on it. New rubber tread. It's gonna be kind of put on almost like a computer. That's what you got to shape. Yeah. And then I'll come. And then at some point they're gonna put that onto the tire. Interesting. So I mean, this is really like, I guess this is really recycling more or less, like you're getting the same kind of value added product out of it. It's a little bit downcycling, but the next guy is going to be get that off. The next thread down. Oh yeah, they put a glue on it, like they threw rubber glue to hold it together. And then some point, oh, I didn't put the tread in. You think that where the tread, like there's gonna be a meeting point for it, if they put it on, but that doesn't seem to be a problem. Maybe it is, like you see the things on the side of the highway. So this is all gonna go into a press, like an autoclave, kind of seal it together. And it ends up looking like a new tire. I put some glue in between. Put the thing together and then staple it. Somehow hold it together. He fixes it and then he puts it in. This is why I would play with it. It's kind of clear about those two parts of it. It already looks like a pretty new tire. Like those kind of. There's an auto. It's like a rack. They'll just do it up and kind of. They'll steam treated and they treat with high pressure. It's like baking things like together. And then in the end, they're gonna come out as town.
Here's Bernie Marino on abortion.
This is not about women's choices.
Bernie. Luckily it's short thing, it's YouTube. I guess they're making money off this. This is not it either. Maybe because I muted it, they're making us watch two of them. Oh, so, yeah, they come out. That's one process. The other process is they're gonna actually mold rubber, like mold rubber. This is the other process. They have rubber. So this doesn't have fat on it, so it's gonna go into a mold. It's gonna go into a mold. They put the whole tire back in like a tire mold, like when they make tires, they usually kind of start that way. This is really a lot like the original tire manufacturing process. Because they're putting a new tread on. Then the treads that come from molds that are into it. This is like a better process. It doesn't have the screen in it, but it's probably the best likely to blow apart. That's still like kind of liquid. We haven't observed yet. But it's kind of liquid fiber type of stuff. So that's got the thread. So it's going to be a clamshell from the setup. That's how they make it. And that's pretty good. And then kind of each kind of I thought that was that they show the whole operation, but depending on your let's see, so you can go back here. Say airplanes are going to be like 7 times or more, trucks like 6. Depends on what kind of truck it is, and then yeah, the airplanes, they're replacing the tires all the time, basically. So you see this on the highway, there's a lot of debate in this about whether that came from retreads or not. So if it has metal in it, there's no way it's a retread. So you see this on the highway and it's got metal in it. That's not the retread. If it doesn't have metal, I think it's a retread. So people have done studies on this funded by the tire and trucking industries that say that these are not retread problems. So, I mean, and then the government is still like debating whether this is a retread problem or not. But the weird thing is, like, if you go to in Africa or in Europe, you will never see this kind of thing. And they have more retreads than we have. So maybe it's just that we have cheap tires, I guess, on trucks or something. I don't know exactly what it is, but anyway, people blame this on retreads. So, and then there's debate over whether that's true or not. Then California is like big on retreads now. They got the, I don't know, there's everything about tires. They have like so much online about it. This
We trust the vehicles on the road with every aspect of our lives.
This is just like why retreads are so great. It's a promo thing. We love retreads, use them in airplanes, use them in whatever. So you can look at that if you want. Actually,
Retreading diverts.
kind of worthless. It's a promo thing from California about retreads. Anyway, we got time. I'm just going to go through the cement thing, I guess. So we got like, anyway, 37% of waste tires go into cement. So cement's this like, you start with limestone, and then you heat it up and you make lime and then CO2. So that's like 8% of the world's CO2 comes from that reaction. Right. So that's like a huge carbon footprint. So it's like 30,000 degrees Fahrenheit. This operation's going on. So it needs a lot of heat to make that work. And at the same time, you have like that calcium lime is going to react with silica, sand, and alumina from clay, or fly ash from the coal plant. And then there's iron that they add iron to it, iron oxide, like, which could come from tires. But basically, that's the combination that makes cement that's going to be mixed with aggregate to make concrete. So you can also mix it with rubber too. So anyway, you can use rubber 2 ways in this operation, but So it's called clinker, and then you grind it up and you get a bag of cement from that, basically. So the fuel for that, to get to that 1600 C, like they're gonna put anything in, so basically they put in like sewage sludge, hazardous waste. They literally put hazardous waste directly into the cement film, and tires. So tires are like the better of the group. So anyway, so there's a video here. Let's see if this is gonna do it. That's a picture of the kiln, which doesn't show you much. There's a place in Ethiopia. I've been to this place. So there's a kiln down here. You drive right by this on a road. So anyway, this is the example that Wikipedia gives for a cement kiln. It's kind of interesting they would go that far to find it. It's not far from the Somali border. It's kind of like a dangerous place to go to. Anyway, so this is in Indiana, like closer to home. So they've invented a method to shoot tires into a cement kiln. This thing runs. Yeah, I'll listen to an ad. This is a mute thing here.
Yes.
I think we've got to listen.
Make you get a bigger tent.
This is only like 5 minutes.
Origin. All pray nourishment for your companions.
Music. It has the power to connect, to heal, and to move.
15
Since
seconds.
2012, the Global
I think
Citizen
you
Festival
have to
has
listen
used
to
that
it.
power to inspire people to help end world
It's not
hunger, and
YouTube,
City has
but
been a
it's
proud
for-
partner since day
for the
one.
newspaper in Indiana. But you can skip through it, but it's only 2 minutes.
Cemex is the largest manufacturer of building materials in the United States, and we're at one of its 11 operating cement plants here in Louisville, Kentucky, and we produce about 1.7 million tons of cement a year. To make cement, you need a source of calcium, which is limestone for us. You need a source of silica, which is sand, and you need a source of alumina, which we either get from clay or fly ash. You need a little bit of iron, and you need a whole lot of heat. For the heat content that we need for our process, we were using essentially about 30 tons an hour of coal and petroleum coke, fossil fuels. We can also use natural
There's a
gas.
coal mine right near there too. in
But starting in
Kentucky.
December 2010, we started using
There's a
tire
ton of
derived
that,
fuel,
so no one wanted
which
to
in our
do it.
kiln are whole tires. And we are using anywhere between 3 to 6 tons an hour of whole tires to help replace our fossil fuel demand,
Looks like
which
they
gives us a
manually
heat
feed it.
substitution of about 10
Some
to
of these
15%.
tires, that looks like a new
Since
tire. Like
December
something done with
2010,
that.
We've used almost 2 million
See these
tires.
operations.
And these are waste tires, scrap.
All right, then it's
boxes,
gonna shoot it into the
tires,
kiln. That's the high point
that
of this.
come from a vendor or different vendors.
They
And
invented
it's
a
allowed us to
tire
replace about
shooting. gun.
22,000 to 24,000 tons of fossil fuels.
That's the gun.
Most everyone is familiar with the baseball pitching machine, and Cemex actually has a patent on a tire pitching machine. Take tires and we compress them in rollers. And then we fire them at about 85 miles an hour, about 110 feet into the hot burning zone of our kiln, where they are consumed within seconds, just a couple of seconds, at 2,600 to 3,000 degrees Fahrenheit. And that's what gives us some of the fuel demand that we need, is that consumption of the tire. The tire is gone within seconds,
That's a lot of
everything is
tires.
consumed. Even the
30
cell
was it
things basically
37%
become
of
part of the
tires?
iron that we need in our recipe for making cement. And so you don't get the black smoke, you don't get the
It's totally
odors, and you don't get
retreaded.
the toxins.
And they don't look
It's
that bad.
wonderful.
I mean, the rims and everything are covered. Anyway, that's the high point of the thing here, but so. Anyway, yeah, international paper, everything's like international paper. So do you guys use tires to burn or where you worked or?
They did for a while, they moved away from that before I,
Yeah, it's hard to find anything like that video about the tire thing at the cement factory with paper plants. There's nothing like that on the internet.
well, paper plants also have their own kiln that they use to reactivate their, I forget what exactly it is, that was on the utility side, but they, we had a quarter-mile kiln that burned just as hot, but to reactivate some of our stuff for separating the pulp.
Oh, I see. Well, that's, what do they use, carbon or something you mean, or activated carbon? Or is it catalyst, activated catalyst?
No, it was, I forget exactly, it's been a while,
Huh.
I've been there.
All right, anyway, so this is kind of like only one of the few things you could find about it. It's like, and most of it's like people complaining. This one, Blockhaven Mill, it says where it is, right, somewhere here. Pennsylvania, but the ones in like New England, they come in New York, they're like complaining about tires. The only thing you can find is like people saying like, don't use tires. You know, so, but I guess they don't know about the black liquor or whatever. And someone should explain to them like what actually is going on at a paper mill. So anyway, so yeah, so that's, yeah, why don't we can kind of end there today, and then I'll kind of pick up on this a week from today. It's like Tuesday, we'll have Kelly come in, talk about the film stuff. So, all right, thanks.